Good afternoon. I'm very happy to be here after 2 years' time again in a meeting face-to-face. I'm honored to be invited by FUE Europe, and I want to thank the President, Dr. Özgür Öztan, and the host, Dr. Tayfun Oğuzoğlu. I'm planning to talk about today coverage value, how I use in my daily practice, and Kebot robotic scanning system, and Kebot mobile, which is an application for smartphones. Is this? The most frequent questions patients are asking to me every day: what is my donor capacity? How many grafts do I need for a good coverage? And the interesting part, every clinic, every doctor is giving a different answer. Coverage is related by 4 components, and we have 2 major components: the number of the hair and the thickness, the caliber of the hair. Minor components that we cannot control: structure of the hair, wavy, curly, and straight, and the color contrast between the hair and the skin. Coverage value is the mathematical way to calculate the coverage by using the caliber of the hair and the number of hairs per square centimeter. What we are doing, we are simply multiplying the number of the hair with the thickness caliber of the hair in millimeter, and we are finding a number, and we call that coverage value. I just want to share how I use this in my daily practice. The first step in the morning, we are taking identical photos of the patient. I need same light, same direction, and same angle, and that's the reason I use key photo for the photos. Before shaving the hair, I need samples from different parts of the donor area, and by using micrometer, I'm calculating the caliber of different parts. After shaving his hair, I am determining the donor area and calculated each area in centimeter square: temporal, parietal, and occipital parts. I use macro photos by using dim light and using these photos in an application, hair counter. By using hair counter, we are counting each hair and the calculated density of the hair, so it will be possible for me to calculate coverage value of different parts. According to coverage value calculation system, I made the operation plan, and here you can see from the right temporal area, we are planning 250 grafts with estimated 1.9 hair per graft. Also, another assistant is focusing on the left parietal area, which is 40 centimeters square area, and we are planning 750 from that part with the average of 2.0 hair. To control hair per graft averages, another team is focusing on extracted grafts. By using biomicroscopic system, they are separating single, double, triple grafts.
1, 2,
and
3,
by using
4.
an application, graft calculator, we are reflecting on the screen, so also the patient has a chance to follow his surgery: how many grafts extracted, how many grafts left, what is his hair per graft average from that area. And also during the Istanbul workshop, I will do the same thing. You have a chance to follow all the surgeons' extraction performance, the graft quality, miniaturization rate, telogen rate, transaction rate. Also, patients feel more confident when they follow their surgery by using this system. In the last 5 years' time, I operated 3,153 patients from 68 different countries. I had a chance to publish average coverage value of these all worldwide patients. The highest coverage values are coming from Indian patients, and the lowest coverage values are mostly from Scandinavian patients. Calculation is the most important thing for donor harvesting plan, because if you have a coverage value around 7, you can maximum extract 15% of hair ratio. But if it is around 20, which is very rare, you have a chance to extract 70% of hair ratio. So calculation is the most important thing for harvesting plan. I have some difficulties in my calculation system. First of all, you can take only few samples from the donor area. You can maximum cut 10, 15 hairs and you can measure it. And even you can measure it in a correct way. It's not representing all the donor area because numbers are changing from up to down, right to left. Another problem, hair is not round. It has an elliptical index. It was published by British Journal of Dermatology in 1997. Different races also has different elliptical index. East Asians has more round hairs, but Africans has higher elliptical indexes. When we are trying to measure hair caliber, we are using micrometers. Micrometers mostly measure the short axis of the hair. And if you have a chance to turn around, you will see that you will get different numbers. And another problem is the compression of micrometer is pressing and compression of the hair shaft. And mostly we are getting lower numbers of the reality. We made a study with Dr. Alp Bayramoğlu. We randomly choose 3 different patients and take samples from their donor areas, temporal, parietal, occipital. And from every part of the donor area, from superior, mid and inferior parts, we take 10 hair samples. We measure them by using micrometer and we send all these samples to the university for electron microscopy scanning. In this study, I randomly chose 3 patients and divided the donor area, temporal, parietal, occipital parts. And from each part of the donor area, I took 30 samples, 10 from the upper, 10 from the middle, and 10 from the lower parts, and temporal, parietal, occipital. I checked the caliber of the hair by using manual micrometer system, and I scanned these areas by using Kebot again, and then I sent these samples to electron microscopy laboratory to Dr. Alp Bayramoğlu.
This is the electron microscopy laboratory of Acıbadem University, and as you see, this is the equipment we used here. And we got the hair samples from ASMED clinic from 3 patients from Dr. Koray Erdoğan. We got these hair samples. These 270 hair samples, actually we placed them, each of them, on these stages. And there are 2 important things here. One of them is we placed them vertically for the correct measurements. And also, we measured their proximal part. That means closer to the skin. And we got the short and long axis measurements from there.
When we got electron microscopic images, we realized that there are many variations. Even from the same part of the donor area, we see many different calibers and different hair elliptical indexes. We scan all these patients also by using Kebot, and we found a correlation between the long axis and Kebot results. I want to explain more. This graphic is a histogram. What is histogram? And you can see the horizontal line and vertical line. On the horizontal line, you see the thickness of the hair, the calibers, and on the vertical line you see the number of the hairs, the percentage of the hair. It's showing me, when you scan area by using a Kebot, you are getting a similar histogram like that. And also we got an histogram when we use electron microscopy. We have another histogram, so we have a chance to compare these histograms, and we found 2 important results. The first result, the long axis is correlated with Kebot results, and the short axis correlated with micrometer measurements. So it's important. And another observation, when we scan the donor area of the patients, hair elliptical index is changing race to races, but even in the same patient, in the same area, we are getting different elliptical indexes, 1.5, 1.8, sometimes 2.1. And another observation from upper side of the donor area, when you are going to the lower part, the caliber of the hair is slightly getting thinner. We observed all these 3 patients. So when we use manual systems like micrometer, we have 2 problems. One of them, for a scientific result, you have many samples from different parts of the donor area. And another problem is it will be correlated with the short axis only. So I focus on optical scanning system. That's the reason when I started to work on Kebot. And I want to share also this study with you. This is my solution, Kebot, robotic scanning system. We are evaluating patients in two steps. First, before the operation evaluation and after the surgery. Before the operation, what Kebot is doing, first of all, calculating the donor area, how many centimeters square, and counting the number of the follicles from each area. Counting the number of the hairs, giving us the average caliber of hair from different areas. After surgery, Kebot is scanning first the donor area, how many holes we created in the donor area, and then checking the recipient area, how many grafts we transplanted, and what's the density of the recipient area that we transplanted.
Kebot is a vision and artificial intelligence-based robotic system. It has two camera systems on it. The first camera system allows us to capture 3D model of the head. The second camera system has a very high resolution sensor, and it allows us to capture the head images at 5-micron resolution. We capture each and every follicle in the head, and we analyze each hair in each follicle so that we are able to determine the exact thickness of each hair in the head.
We performed a series of anonymized studies in this clinic, and the initial studies have showed us that there is large patient-to-patient variation. That was the one thing it showed, and the next thing it showed was that the commonly used tool, which is the micrometer, is only correlated with the short axis of the hair. So this led us to design the next set of experiments, where we had a one-to-one matching between the robotic measurement and the scanning electron microscope measurement. Now, these studies have showed us this time robotic measurement was able to capture the long axis, which is clinically much more valid and will form a basis for the clinical applications. As a next step, we are planning to design studies where we will look at the clinical outcomes, both from the patient perspective and the physician perspective, and then try to correlate these measurements with also these clinical outcomes.
This is Kebot Mobile. It's an application for smartphones. And we know that the caliber and the density is changing in different parts of the donor area, and it's not easy to make it manually in every area. So this application will help you for that. I will show you how it works. Kebot and login and hair analyze. You choose hair analyze. For example, we are choosing an area, left temporal area. I am touching it. And then focusing on left temporal area, taking a photo, use the photo, and send. I'm sending to the server. This is the same server with the Kebot. So it's analyzing now, and now it's sending me the results. You can see here. So it's now I got the analysis. You can see here from the left temporal area, I got follicular unit number, calculated density, caliber, estimated coverage value from that area. So you can use it many times from upside, downside, so you can get easily an average. In this last study, we frame a certain area and we marked each follicle and hairs from that area. We cut this hair and sent to electron microscopy laboratory, and also we scan the same area by using Kebot and Kebot Mobile. In this study, I only use one patient, and I frame a small area from the donor, and I cut each hair. But before cutting them, I mark. So this time I know I'm checking caliber of the which hair, and I try to find out the long axis and the short axis also in this case, and I scan the same area, Kebot and Kebot Mobile. And I send the hair samples to electron microscopy laboratory again, and this is my result. According to our results, we statistically find significant high correlation between electron microscopy, Kebot, and Kebot Mobile results. Now I feel more confident for the future of FUE. In the last 2 months, I score telogen rate, miniaturization rate, and transaction rate of the graphs we extracted. So we are also updating a graft calculator. So in a very short period of time, you will see transaction rate, miniaturization, and telogen rate here. So after the surgery, you will have a chance to see also all these statistics. I think this is very important because Kebot is giving us a histogram. This histogram is related with the caliber of the hair. And I'm trying to find out a correlation with the telogen rate and this histogram. I think this is important and will change something. I'm planning to present this for the first time in Istanbul workshop. Next year I will be the host for Istanbul workshop, and I want to invite all of you. You can imagine how many times, for nearly 5 years I'm working on Kebot and Kebot Mobile. And probably it will be ready, because it takes time. It will be ready for sale till next summer. And thank you for listening to me. Thank you. See you later.